So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have these JAMB repeated questions here to solve on the topic acids, bases and salts. So guys, here we're going to majorly focus on acid-base titration. So let's consider the first question here. It says 25 cm cube of 0.125 moles per dm cube sodium hydroxide solution required 15.0 cm cube of a solution of tetroxosulfate 6 acid for complete neutralization. What is the mass concentration of the acid solution? So guys, we are looking for the mass concentration here. So we need to understand that mass concentration will be in gram per dm cube. So we're simply going to write the mass concentration. So let's go ahead here and write gram per dm cube. So the mass concentration is in gram per dm cube, and then the molar concentration is in mole per dm cube. So you need to take note of this. This is the mass concentration. So guys, we're going to find the mass concentration, but first of all, here we need to write the equation of this reaction. So the equation of this reaction will be such that the sulfuric acid here, that's the tetroxosulfate 6 acid here will react with the base here, which is sodium hydroxide, to give us, so here we have to use excess sodium hydroxide here so that we can get sodium tetroxosulfate 6 and water. So guys, now we've established the equation of this reaction. We also need to understand that in this reaction we will have them in the ratio 1 is to 2 is to 1 and 1 here. So this is their corresponding ratios here for the reactants and the products. The number of moles of acid reacting here is 1 and that of the base is 2 here. So let's go ahead and involve this equation. The general equation we already know, Ca, that's the concentration of acid, times Va, that's volume of acid, times number of moles of base, that's Nb, is equal to Cb, that's concentration of base, times Vb, that's volume of base, times Na, that's number of moles of acid. So guys, here we want to get the concentration of acid. Having that from the question, we've been given the volume of acid, and then we've been given the concentration of base and as well the volume of base. So we need to understand that here, if we make Ca the subject of the formula here, we are going to have Cb, Vb, Na over the coefficients of this Ca, that's Va, Nb. So guys, with this, what's the concentration of base from the question? In the question, they said 25 cm cube of 0.125 moles per dm cube sodium hydroxide. So it means 0.125 is the concentration of the base, because that's the concentration of sodium hydroxide, and sodium hydroxide is the base here. So let's check out the volume of the base. They say 25 cm cube of this, so the volume of base here is 25 cm cube. And then what's the number of moles of acid? From the equation of the reaction we have here, the number of moles of acid will be 1, because 1 mole of tetraisosulfate 6 acid reacts with 2 moles of the base. So guys, over here, down here, we'll have volume of acid, and that's 15.0 cm from the question given to us, then times number of moles of base, that's 2 from the equation of the reaction we have. So guys, if we do that, let's quickly go ahead and make use of our calculator. So here you have 0.125 times 25, and that's 3.125. So if you multiply this by 1, it's still 3.125. So we'll just go ahead and write 3.125 here, 3.125 over, so here below we have 15 times 2, and that's 30. So we'll just simply go ahead and write 30 here. So this will be equal to 3.125, 3.125 divided by 30. So that's 0.104, we can see from here. So 0.104, and this is in mole per dm cube. But guys, we are looking for the concentration in gram per dm cube, because we are looking for the mass concentration, and it should be in gram per dm cube. So we are going to, we'll go ahead and wipe this out. So let's quickly wipe this out here and solve from here. So guys, having that already here, now we have the concentration in moles per dm cube, and that's the molar concentration. We can actually get the mass concentration here by simply multiplying the molar mass by the molar concentration. So guys, let's check out the molar mass of this acid. Remember, the acid is H2SO4. So if we want to check out the molar mass, H2 is 1 times 2, right? H is 1, then multiplied by 2, that's 1 times 2, then plus sulfur is 32, and then O4, oxygen is 16 times 4. So guys, when we add this up together, that's 2 plus 32 is 34. Then 16 times 4, go ahead and do 16 times 4, and that's 64 plus 34, that's 98. So guys, the molar mass here is 98 gram per mole. So if we multiply this by 0.104 mole per dm cube, we're going to get, let's multiply this. If we multiply this by 0.104, that's 10.19, approximately 10.2 gram per dm cube. And guys, this is the mass concentration of this substance, of the acid here. So guys, the answer to this question is option C, and that's 10.2 grams per dm cube. So that's it for that question. So guys, let's go ahead and check out the next question here, and that's question number 2. So guys, question number 2 says, which of the following solution containing only one hydroxyl ion will liberate hydrogen when reacted with magnesium metal? So guys, the options we have here, we have A, 1.0 times 10 to the power of negative 6, B, 1.0 times 10 to the power of negative 12, C, 1.0 times 10 to the power of negative 2, and then D, 1.0 times 10 to the power of negative 4, all in moles per dm cube. So guys, looking at this, we don't need to solve anything. Option B here is the correct answer, for the fact that this is 1.0 times 10 to the power of negative 12 moles per dm cube. So it will have an alkaline pH of 12, so which means it's the only alkaline here, and that's the option that will liberate hydrogen gas when reacted with magnesium metal. So let's look at the next question, question number 3. It says, what is the basicity of the propanoic acid? So we have A 3, B 1, C 0, D 2. So guys, propanoic acid is actually a monoprotic acid, so the basicity is 1. So option B is the correct answer to this question. So let's consider the next question, guys. Question number 4. The question says, water can be obtained as the only product during the A, neutralization of an acid by a base, B, electrolysis of brine, C, combustion of hydrogen, D, combustion of hydrocarbons. So guys, option C is the correct answer to this question, and that's combustion of hydrogen. So what really happens during the combustion of hydrogen? That hydrogen burning in oxygen. So let's go ahead and write an equation of this reaction. If I have hydrogen gas here, let's say 2 molecules of this, then plus oxygen, the product will be so this is oxygen is a gas. So guys, that's the equation of the reaction, and combustion of hydrogen is the actual answer to this question. So let's consider the next question, guys. That's question number 5. So guys, the question says neutralization involves a reaction between hydronium ion and A, hydroxyl ion, B, chloride ion, C, nitrate ion, and D, carbonate ion. So guys, the answer to this question is option A, and that's hydroxyl ion. So in neutralization reaction, it's simply the reaction between an acid and a base or alkaline to yield salt and water only. So guys, having this, the hydronium ion is an acid model, so whereas the hydroxyl ion is a base model. So the reaction between the two is a neutralization reaction. So let's consider the next question, guys. That's question number 6. It says, when sodium reacts with water, the resulting solution is A, acidic, B, weakly acidic, C, neutral, D, alkaline. So guys, if sodium should react with water, let's write out the equation of the reaction. We're going to have so if I make this 2 and I make this 2, I'll have sodium hydroxide, which is alkaline, plus hydrogen gas. So guys, that's it for this question. So let's go ahead and check out the next question. And that's question number 7. Guys, the question says 10.0 dm cube of water was added to 2.0 mole per dm cube of 2.5 dm cube solution of HCl. What is the concentration of the solution in moles per dm cube? So guys, for us to get the concentration of the solution in moles per dm cube, we need to apply the dilution theory. Guys, knowing fully well C1V1, yeah, let's zoom in and write it down here. C1V1 is equal to C2V2. So guys, making use of this, our C1 is already given here to be the first concentration, which is 2.0 mole per dm cube. So our C2 C2 is not given, and that's the one we are looking for. So our V1 is the initial volume, and that's 2.5 dm cube, and then our V2 will be this initial volume plus the volume of water, and that's 2.5 plus 10 dm cube. So that's 12.5 dm cube. So guys, having gotten this, let's go ahead and wipe this off. We're going to still make use of our equation C1V1 equals C2V2. So in order to get C2 is going to be C1V1 over V2. So we already know that C1 is the initial concentration, which is 2.0 moles per dm cube, and then V1 is the initial volume, which is 2.5 dm cube, and this will be over V2, which is 12.5 dm cube. So guys, let's go ahead and use our calculator here, and that's, we're going to do 2.0 times 2.5, and that's 5. So we are going to divide this 5 by 12.5. 12.5, that's 0.4 guys. So C2 is equal to 0.4 moles per dm cube. So guys, that's the answer to this question, and that's option D. So let's go ahead and check out the next question. That's question number 8 here. Question number 8 says 20 cm cube of 2.0 molar solution of ethanoic acid was added to excess 0.05 molar sodium hydroxide. The mass of salt produced is A 2.73 grams, B 2.50 grams, C 4.54 grams, D 3.28 grams. So guys, the first step is to write the equation of the reaction here. So we are simply going to write the equation of the reaction, and that's ethanol here reacts with sodium hydroxide to yield sodium ethanoate and water. So guys, with this we can tell that 1 mole of ethanol will produce 1 mole of sodium ethanoate. So also having that, we have 2 moles of 2 moles per dm cube of the ethanol. So the concentration of this ethanol is 2 moles per dm cube, and it's yielding 2 moles per dm cube. Of the sodium ethanoate here. So with this, we know that the volume given to us here is in cm cube, but then we know that 1000 cm cube is equal to 1 dm cube. So since we have 20 cm cube of sodium ethanoate, so it means to get the actual number of moles of these reactants and products here, we have to multiply the volume here by the molar concentration, and the volume here is 20 cm cube, and that's 20 over 1000 times 2.0 moles per dm cube. So 20 times 2 over 1000 will give us, so this will be 0.04 moles. So this entails that actually 0.04 moles of the ethanol will give us 0.04 moles of the sodium ethanoate. So let's go ahead and wipe this top part. So having gotten this, the next thing we want to get is the mass of the salt produced. Now we already know the number of moles of this salt, and we can actually get the mass of the salt produced when we are able to get the molar mass. So the molar mass of this salt will be atomic mass of carbon, that's 12, plus atomic mass of hydrogen, times 3, that's 1 times 3, then plus atomic mass of carbon here, that's 12, then plus atomic mass of 2 oxygen, and that's 16 times 2, or we can just write 16 plus 16, then plus atomic mass of sodium, that's 23. So guys, we are going to add up this. So when we add up this, we are going to have 12 plus 3 plus 12 plus 16 plus 16 plus 23, and that's 82, guys. So now we've gotten the molar mass to be 82 grams per mole. We are going to multiply this by the number of moles, and that's 0.04 moles. So when we multiply this, we'll have 82 grams per mole times 0.04 moles That's 3.28. So guys, the answer to this question is 3.28 grams. So that's the answer to this question, guys. Let's quickly go ahead and check out the next question, and that's question number 9. So guys, the question says, calculate the volume of 0.05 moles per dm cube tetraoxo of a cis acid that is neutralized by 25 cm cube of 0.1 moles per dm cube sodium hydroxide. So guys, again, here we need to write the equation of the reaction. So we are simply going to zoom right in here to our workspace. So let's go ahead and write the equation of the reaction. So we have H2SO4 plus sodium hydroxide here to give plus water. So guys, again, we need to always put this equation at the back of our mind whenever we are doing anything on titration or any calculation that has to do with titration. So CAVANB is equal to CVBV VB CBVB and A. So guys, here we want to calculate the volume of the tetraoxo of a cis acid. So actually we are going to just calculate for VA, and that's the volume of acid. So let's go ahead and input the values for everything while making VA the subject of the formula. So CBVB NA over CANB. So the concentration of the base as given to us in the question is 0.1 moles per dm cube. Then the volume of base is 25 cm cube. And then number of moles of acid is 1. From the equation of the reaction, you have 1 here, and you have 2 here, and this is 1 and 1. So this would be 1. So whereas the concentration of acid is 0.5 moles per dm cube, and then number of moles of base is 2. So guys, we'll go ahead and calculate this. 0.1 times 25 times 1, that's 2.5. So let's go ahead and write it down here. 2.5 over so let's do 0.5 times 2, and that's 1. So this will be 2.5 over 1, and that's 2.5. So guys, the answer to this question is option B here. That's 2.5 cm cube. So let's quickly go ahead and check out the next question. And guys, that's question number 10. it says, okay, in fountain experiments, water turns A, pink, B, grey, C, red, D, blue. So guys, the answer to this question is option C, and that's red. In fountain experiments, water turns red. Actually, it's used in the preparation of hydrogen chloride. So guys, let's consider the next question. Question number 11. It says, a solution of sodium hydroxide containing 0.6 gram in 250 cm cube of solution has a concentration of A, 0.96 mole per dm cube, B, 0.15 mole per dm cube, C, 0.04 moles per dm cube, D, 0.06 moles per dm cube. So guys, from the question here, we have a solution of sodium hydroxide containing 0.6 gram in 250 cm cube of solution. So what we have to do is, first of all, find the concentration in gram per dm cube, and that's the mass concentration. So guys, it's actually pretty easy for us to do this, because alright, let's zoom in. Let's go ahead and zoom into our workspace here and solve these together. So let's see, to find the mass concentration, that's the concentration in gram per dm cube, that's the mass here over the volume. So actually the mass here is 0.6 grams. So the volume is 250 cm cube. But guys, this 250 cm cube has to be converted to dm cube, and that's 250 over 1000. Remember, we stated earlier on that 1 dm cube is 1000 cm cube. So with this, that's 0.25 dm cube. So guys, having our mass concentration as mass over volume, we have 0.6 over 0.25. So let's go ahead and check this out with our calculator. That's 0.6 divided by 0.25. That's 2.4, guys. So we're going to write it down here, 2.4 gram per dm cube. So guys, let's also recall that molar concentration is mass concentration over molar mass. So the mass concentration we've already gotten here, and the molar mass we can simply calculate. So remember, the compound here is sodium hydroxide. Sodium hydroxide is NaOH. So to find the molar mass, that's the atomic mass of sodium, which is 23, plus atomic mass of oxygen, which is 16, plus atomic mass of hydrogen, which is 1. So let's use our calculator here. 23 plus 16 plus 1, and that's 40. So guys, this will be 40 here, and that's the molar mass here. So the molar concentration here will now be the mass concentration, which is 2.4 over the molar mass, which is 40 gram per mole. So let's use our calculator here. 2.4 divided by 40, that's 0.06 mole per dm cube. And guys, that's the option D here. The answer to this question here is option D. So let's go ahead and check out the next question. That's question number 12 here. We use 24 cm cube of a nitric acid solution to completely neutralize 25 cm cube of a standard solution of sodium hydroxide with a concentration of 0.1 mole per dm cube. Calculate the concentration of the nitric acid solution. So guys, for this, as always, we can use the formula C1V1 is equal to C2V2. So guys, here we already have the volume of the nitric acid here, and that's 24. So we're looking for the concentration. We have the volume of the base here, and that's 25 cm cube, and then we have the concentration of the base, and that's 0.1 cm cube. So guys, now we can simply solve, make C the subject of the formula, make C1 the subject of the formula. So we'll have C2 V2 over V1. So here we simply have 0.1 times 25 over 24. So this will give us 0.1 times 25 is 2.5. Then when we divide this by 24, we'll have 0.104 moles per dm cube. So 0.104 moles per dm cube is the answer to this question, and that's option B here. So guys, let's quickly go ahead and check out the next question. That's question number 13. It says soluble triazocarbonate 4 are prepared by bubbling carbon 4 oxide in A. tribasic acid, B. alkalis, C. dibasic acid, and D. monobasic acid. So guys, the answer to this question is option B, and that's alkalis. So let's look at the next question, question number 14. It says 0.25 moles of hydrogen chloride was dissolved in distilled water, and the volume made up of 0.50 dm cube. If 15.0 cm cube of the solution requires 12.50 cm cube of aqueous sodium triazocarbonate 4 for neutralization, calculate the concentration of the alkaline solution. So guys, here again we need to state out the equation of the reaction. So let's zoom into our workspace first. So the equation of the reaction here, 2HCl plus sodium triazocarbonate 4 will yield this salt, that's sodium chloride, salts, plus water, then plus carbon dioxide. So guys, with this, we know that 2 moles of this will require 1 of this. So in that case, we can simply state it out here. 2 moles of HCl requires 1 mole of sodium trioxocarbonate 4. Therefore, from the question, they said we have 0.25 moles of HCl, and what would that require? In order for us to get this, we simply cross this. So multiply this to this and divide by this. So we have 0.25 times 1 over 2. So this will give us, let's punch here, 0.25 over 2. That's 0.125. So now we've gotten the number of moles of sodium trioxocarbonate. So let's wipe this area. So now that we've gotten the number of moles for sodium trioxocarbonate, you can just write it down somewhere. You just write it down here. And that's 0.125 moles. So the next thing we are going to do here is, in the question they said if 15.0 cm cube of the solution requires 12.50 cm cube of aqueous sodium trioxocarbonate. So let's go ahead and write 15 cm cube here. That's like 15 over 1000 dm cube. So 15 cm cube requires 12.50 cm cube. So 15 cm cube of the solution requires 12.50 cm cube of the aqueous sodium trioxocarbonate 4 for neutralization. So we have to calculate the concentration of the alkaline solution. So before then, we can now say, since 15 cm cube requires 12.50 cm cube, but then 0.50 dm cube was used. So 0.50 dm cube is the same as 0.50 times 1000, that's 500 cm cube. So we'll simply say 500 cm cube that was actually used in the preparation requires what? So here we'll cross and multiply this, and then we'll have 500 cm cube times 12.50 over 15 cm cube. So 500 cm cube times 12.50 cm cube. Now we're going to divide this by 15. That will give us 416.67 cm cube. Now to convert it to dm cube, we are going to divide by 1000. That's 0.417. So simply here, now we've gotten to this point, we've seen the 0.417 dm cube, and that's the volume here. So we have the number of moles and we have the volume, and then we are looking for the molar concentration, and the molar concentration is simply the number of moles over the volume. So we're simply going to wipe this off, and then we'll calculate for the molar concentration. So in this case, we'll have 0.125 over 0.417. (0.125) divided by 0.417. That's equal to 0.2998, which is 0.30 moles per dm cube. So guys, that's the answer to this question, and that's option D here. So let's go ahead and wipe this, and let's consider the next question. So guys, the next question here is question number 15. It says, which type of acid is found in vinegar? A. Nitric acid, B. Sulfuric acid, C. Acetic acid, and D. Hydrochloric acid. So guys, the answer to this question is option C, and that's the acetic acid. So this will be the end of this video, guys. If you enjoyed this video, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, share this video with your friends to enable us reach out to more people. And guys, we encourage you to join our channel membership. If you're not a member of this channel, please do join our channel membership in order to get premium information on JAMB. So see you next time. Thank you for watching this video, guys.